Welcome back to another episode of Math with Dr. Math. We are here subtracting complex exponents. So here we go. Copy this down, folks. We are subtracting these very complex forms. And if you note, just as we discussed in previous lectures, I'm going to have to distribute my negative sign. So let's go ahead and distribute this negative sign. Don't forget, for private tutoring, you're going to call 1-800-MATH with Dr. Math. So we have 2i minus 6i. So notice nothing happens with those first two terms, as I'm highlighting here with my nice arrow. And this negative sign is going to get distributed as such. All right. So notice I put a 9 there just to show you common mistakes that students make, not me. But it should have been a 3i, right? So we go ahead and distribute our negative sign. We are not multiplying. We are not foiling, so don't fall down that trap. All right. And if you listen to our studio audience here tonight, you are going to see that they suggested we combine our like terms. So let me color code this. And so we are left with negative 9 plus 5i. So that's all we're doing. We are combining like terms. So let's take some calls from our callers today. Miranda's calling from Salinas. Go ahead, Miranda.
Can you write it 5i minus 9, or does the I always go in the second term?
So the question from our caller is, can we write this as 5i minus I? That is okay. I am not going to be marking off points, but the correct writing would be the first. And that's what you're going to see for those of you taking on other math classes with not so terrific math instructors. All right. So there's our first problem right there if you want to copy it down. So while students are copying this down, we're going to take a short commercial break, and we'll be right back at KSJ Dr. Math. I want to apologize to our viewers at home. Our production studio's technician that's now fired forgot to hit record. So go ahead and copy down this problem. We are multiplying complex numbers. All right, so let's get to it, Johnny. So let's move this up, as we say in TV world. So we're going to distribute. So 2i times 3i is 6i squared. And 2i times negative 4 is negative 8i. All right, so all we're doing is foiling. All right, and then we go ahead and distribute the negative 5 times 3i, and we are going to get 15i. And then we multiply the negative 5 times the negative 4.
Minus 15i.
And I was just seeing if our audience is here with me. So good. It's a minus sign right there. Right. I saw people sweating. They're getting a little nervous here in the studio. I wasn't sure if it was getting hot. All right. And then we get plus 20. And just a reminder, I squared, what is I squared going to do to our signs? Exactly. It's going to change our signs, as our enthusiastic student audience has told us. So we end up with negative 6. And what do we get when we combine those like terms right there? Negative 23i plus 20. And now we go ahead and continue combining our like terms. So negative 6 plus 20 leaves us with 14. And so we're left with 14 minus 23i. Is there anything else we could do here? No. Well, folks, you know, I come to work, I just do my job, but I'm glad to get the recognition that I get. It's not easy. All right, so let's continue the march here on KSB Math with Dr. Math. So we're going to look at rationalizing the denominator because, again, as we discussed in class, you never know when this might save your life. So we're going to end up with 2 all over 3i. Because you are such great mathletes, let's change the top to 2 minus 5i. Let's spice it up a little bit. All right, we're going to take this up a notch. And so as a reminder, we never want a 3i on the bottom, right? Because you never want imaginary numbers in our denominator. So what we're going to do is we're going to rationalize this. All right, so let's rationalize this, and let's see what our studio audience has to say. What are we going to multiply by, guys? Good. So what's nice about this is I can multiply by 3i or by negative 3i, depending on what side of the bed you woke up on. They're both fine. All right. So it's optional. It's optional.
Why is it optional?
Why is it optional? If you stay with us in our next segment called Why to Discipline Your Kids, you're going to find out why. But right now, we're just going to stick with the positive 3i. All right. So let's go ahead and let's put parentheses because I do not want to forget to distribute. All right. So let's multiply 2 times 3i, and we're going to be left with 6i, and then we're going to multiply 3i times negative 5i, which leaves us with negative what? Good, 15i squared. And again, a reminder that that I squared is going to do what to your signs? Good, it's going to change those signs. And on the bottom, we are simply left with 9i squared. All right. Excuse me, yes, go for it. Your question. Julie from Mississippi is asking why we got the 9. So notice, Julie, 3 times the 3 gave us that 9 right there. Thank you. So now we continue, and we have I squared is going to do what to our signs? It changes this I squared is going to change this 9 to a negative. And then the 15 to a positive. All right, so I'm getting another. My phone line is just heated up. So let's go with Fabian from Kansas City. Fabian, you're with Johnny. Go ahead, you're on the air.
So basically, whatever's attached to the I changes the sign.
Oh, great question. We have a first-time caller, and what he just noted is not what's in front of the I, but whatever's in front of the I squared. That's what changed. I squared, which is different from ice cream, right? All right. So we are left with 6i plus 15i. That's what you have upstairs. And downstairs, that 9 changes to negative 9. Notice on top, what number can you factor out, if any? A 3. So just as our enthusiastic crowd mentioned, we'll take out the 3. And you're left with what in parentheses? 2i plus 5 over, good. I'll just put 3 times negative 3, just so I could see that these 3's will cancel. Go for it.
Can you just divide all 3 terms by 3?
You could divide everything by 3, and that's essentially what we're doing. Absolutely. So if you want to write that, that's fantastic. So we go ahead and we write down what's left. And notice, I will not mark off if you put the I first, but traditionally we always leave the I at the end because we do want to think about other people first. Thank you. All right, folks, so we're running on the last 10 minutes of our program, and we're going to play a little game called Do What I Do. All right. So go ahead and copy this down, and we are going to solve. And actually, let me spice things up a little because I did notice we have a lot of people in our studio audience that made a trip from far away, and I do not want to disappoint. All right. So we have this radical equation here, and I'm going to do something that, to be honest, hasn't been seen on TV before. So if you're listening, don't worry, because you're not going to see this either. So what we're going to do is we're going to solve. So our first step in solving this is what? subtract x. Good. So if you heard something wrong, don't listen to them. So we are left with the square root of x plus 3 equaling 3 minus x. All right. So we have the square root there. And how do I get rid of a square root? I square both sides, right? We had to escort someone out of our audience last class because they said, just don't write it again. No, that is not correct. So we're going to square both sides. And when you square both sides, just make sure that you have 2 copies. Yes, uno, dos, all right, because we are in France, all right. So we go ahead and distribute. What's going to happen with my square root? It cancels. It cancels. And you're going to distribute, right? You're going to FOIL everything out from that second term. So in doing so, you're left with 9, because 3 times 3 is 9, as a studio audience member pointed out last time. And then we have minus 3x, another minus 3x.
Okay, yeah, so, wait, yeah.
Security? Yes, yes. And so this is what we're left with. Okay, you got it. Okay. And so now we have a quadratic. So we have a quadratic, so notice we are going to set one side equal to what? To 0. All right. So let's go to our phone lines. Any questions? Any questions so far? Rando from New York.
Okay, shouldn't you add 3x together?
Yes, and we are going to do that. I'm just moving everything on one side. So you're absolutely right. We are going to combine like terms. Very good.
Okay.
So we get 0 on one side, and after combining our like terms, we're left with x squared minus 7x plus 6. So after you combine your like terms, that's what we're left with. Hopefully you could what? Hopefully you could factor. Are we going to be able to factor this one? Yes. So let's do that. Let's factor it. So we factor this and we end up with x minus 6 and x minus 1. So we go ahead, we set them equal to 0, and you end up with possibly 6 and possibly 1. And of course, we have to do what at the end? Check. So what we're going to do is when we plug in the 6, unfortunately, that's not going to work. So our only answer in this case is 1.
Negative.
All right, America, welcome back to another episode of Math with Dr. Math. Here we have a rational expression that we're going to be working with. And don't confuse this with a rational equation because this is not equal to anything. All right. So as you're copying this down, let's go ahead and get started. Hopefully we recall that the first thing we're going to have to do is find our LCD, which in this case happens to be x plus 1 and x minus 2. So what we do with the LCD is we are going to multiply each fraction, right? We could even turn this last integer into a fraction. We're going to multiply each fraction by what it's missing, what its denominator is missing from the LCD. So what do I mean? Let's take a look here. So let me copy down the problem again. And I want to focus on, again, my LCD here. So this is my LCD. So if I take a look at this LCD and I compare it to my first fraction, well, I could see I have the x plus 1, but I'm missing the x minus 2. So what we're going to do is we're going to go ahead and we're going to multiply both the numerator and the denominator by the missing piece, which is x minus 2. Because our goal is to have every single fraction here with the same denominator. All right, so that one was missing the x minus 2. This one right here is missing the x plus 1. So we'll go ahead and multiply it by the x plus 1. Whatever you do to the bottom, you do to the top. And we said that this minus 4, we're going to go ahead and write it over 1. And notice that's missing both of these pieces. All right, it's missing both of those pieces right there. So I'll go ahead and multiply it by both the x plus 1 and x minus 2. X plus 1 and x minus 2. All right. So that's what's going on there, folks. So now it's just a matter of distributing. So let's go ahead and distribute like it's 1999. So I got 2 times x, which is 2x. I have 2 times negative 2, which is negative 4. And that's all over the LCD. I have plus, I'm going to go ahead and distribute this 1, but notice that 1, when you distribute it, does not change anything. So I'm left with x plus 1, and that is over my LCD. And I get minus, notice this 4, what I'm going to do is I'm going to distribute this 4 last. So what I'm going to do is I'm first going to FOIL, right? You're going to distribute this piece. So what I'm going to do is I'm going to keep the 4 on the outside. And again, I'll take care of business at the end there. So I'll go ahead and distribute x times x gives me x squared. X times negative 1 gives me negative 2x. 1 times x gives me plus 1x. And 1 times negative 2 gives me negative 2. And that's still all over the LCD. All right, and my last step is going to be to distribute this negative 4 to all these pieces. All right, so let's go ahead and let's do that. So I'll put equals. Let me change my color here because members of my studio audience is telling me that's a little hard to see. So let me change my color. So I end up with x plus 4. And I'm just going to have one big fraction here all over my LCD. Plus x plus 1, right? And then don't forget, I'm going to distribute this negative 4 times everything. So I'm going to end up with minus 4x squared plus 8x. Don't forget, you're distributing the negative 4 minus 4x plus 8. So all we did was multiplied everything in these parentheses by negative 4. You distributed the negative 4 times every single piece. And now we're going to go ahead and combine all our like terms. Combine our like terms. So on top you get negative 4x squared. I have 2x plus x is 3x plus 8x is 11x minus 4x, and that's going to leave us with 7x. So let me write that down. Plus 7x. And then for our constants, we are going to have, let me choose a different color here. Let's see if this works. Let's see how this writes. All right, so let's see. Nah, that's not going to be as good, so I'll circle them. I have the negative 4 plus 1 is negative 3 plus 8 leaves us with minus 5. So we're left with minus 5. All over LCD, which was x plus 1 times x minus 2. And I try to factor that. Can't factor it. So there's our final answer right there. All right, folks. Hopefully that made sense. All right. For this problem here, let me go ahead and write the instructions. It will say to solve. So let's go ahead and solve this equation right here, radical equation. So before solving this, I'm going to make sure that all my denominators are factored, because we know that we are going to want to find the LCD. So to find the LCD, we have to make sure that our denominators are indeed factored. So let's go ahead and factor this. All right. So first job is factor. With that said, let's go ahead and jot down our LCD. So in this case, our LCD is x plus 5 and x minus 5. All right, so there is our LCD. So this is very different than our last example, because in our last example, we had a rational expression. This is a rational equation. So very different in what we're going to do here. So let me go ahead and copy this down again. So I'm just copying everything down again, so we could perform our next step here. All right, so we're still going to use that LCD, but the way we use it is very different. Now what we're going to do is we're going to take this LCD that we just found right here, and we're going to multiply it times every single piece here. All right, so let's go ahead, and I'm going to take a copy of that, and I'm going to multiply it times the very first piece right here. So I'm going to multiply that times the 4. Yeah, you like how that happens in TV land, right? We're going to take that same LCD, and we're going to multiply it times the 2. All right. So I'll take that, and I'm going to multiply it times the 2. And then I'm going to take that same LCD, and I'm going to multiply it. Oops. Got a little hit of myself. I'm going to multiply it times the 32. All right, so your LCD gets multiplied. And notice we're only doing the top here, the numerators, because our goal is to cancel, right? We want some canceling to happen. So for example, this x plus 5 and this x plus 5, those will cancel. All right, so that's the reason why we went ahead and we took this LCD and you multiply it times every single piece here. Even if it's not a fraction, it still gets multiplied by the LCD, because whatever we do to one side, we do to the other side. All right, so let's look at our phone lines. All right, we have Amber from Detroit. So this is Amber's question. In our last example, we multiplied the top and the bottom by the LCD. But for these, you only multiply the top. That is correct, Amber. Thank you for listening to our show. Well, notice this is an equation. So equations we only multiply the top of everything, right? Only the numerators get multiplied by LCD. Versus our last example was an expression. Expressions, you multiply top and bottom by what's missing. So there's a big difference there. Great questions. So again, our phone lines are open at 1-800-ASK-DR-MATH. If you want to chime in, feel free. So let's continue. So x plus 5s, they cancel. The second fraction right here, we see the x minus 5s. Those will cancel. So the x minus 5s, they'll cancel. And in our last fraction here, we're going to see both these x plus 5s and x minus 5s cancel. So this cancels with this, and this cancels with that. So let's go ahead and write down everything that did not cancel. So for my first fraction, we were left with the 4 and x minus 5. Our second fraction, we're left with 2 times x plus 5. And for our last fraction, we're just left with 32, because everything canceled besides that 32. Nice. So this one's actually nice to solve. It's not going to be a quadratic. So let's go ahead and distribute. So distribute that 4. So we're left with 4x minus 20. We'll distribute this 2. So you're left with 2x plus 10 equals 32. All right, we combine our like terms. So we'll combine our like terms. So we end up with 6x minus 10 equals 32. We'll go ahead and add 10 to both sides. So you end up with 6x equals 42. And we have a caller from table 5. Go on, table 5. You're on the air. Oh, so table 5's just asking me if I could higher it a little because it's hard for them to see. I certainly can. So let me higher everything just because it's hard for them to see back there. Let me remove this. It's not working for me, table 5. All right. This is what I'm going to do. Let's see. Let me do this, table 5. Copy that, new page, paste. There we go. Son of a. All right. There we go. All right. Just so everybody could see. All right. So continuing and solving this, we divide by 6. We divide by 6. So we get x equals 7. So there you have it, folks. X equals 7 after all that work. All right. So let's proceed.